Hello students, now we will discuss problems on mechanics. Question number 1. A block of mass 2 kg rests on the top of a block of mass 8 kg. Suppose this is a level surface. A block of mass m1 is equal to 8 kg placed over it, and on this block another block of mass m2 equal to 2 kg is placed. The combination is dragged along a level surface at constant velocity by hanging a block of mass 2 kg. This is a pulley, and over this a rope is attached to another block of mass m3 equal to 2 kg, which drag the system with constant velocity. Then first 2 kg block is removed from the 8 kg block and attached to the hanging blocks. Find what is now the acceleration of the system and what is the tension in the cord attached to the 8 kg block. Take small g, the acceleration due to gravity equal to 10 meter per second square. Now solution. This is a level surface and pulley is attached to it. See in the diagram. A block of mass 8 kg m1 is placed over it, and on this block another block of mass m2 is equal to 2 kg is placed, and system is dragged with another block of mass m3 is equal to 2 kg by a string with constant velocity over the level surface. We are given m1 is equal to 8 kg, m2 is equal to 2 kg, m3 is equal to 2 kg. Let tension in the string is capital T. See in the diagram, tension is capital T. Free body diagram of mass m3 is, this is mass m3, and free body diagram means mark the force acting on it. The various forces acting on the mass m3 are the tension capital T acting in the upward direction. This is tension capital T acting in the upward direction. The weight of mass m3 acting in the downward direction, that is m3g acting in the downward direction. As the masses are moving with constant velocity, therefore according to Newton's second law, net force will be equal to 0. As for constant velocity there is no acceleration, therefore capital T is equal to m3g. Let it be equation number 1. Now free body diagram of mass m1 and m2 are, free body diagram of mass m1 and m2 is, this is mass m1 and this is mass m2. The force acting on it are, the various force acting on the mass m1 and m2 are the tension T acting in the horizontal direction. This is tension capital T acting in the horizontal direction. The weight of mass m1 and m2 are acting in the downward direction, that is m1 plus m2 into g acting in the downward direction. The normal direction capital R acting in the upward direction. This is normal direction capital R acting in the upward direction. As there is no motion in the vertical direction, therefore capital R is equal to m1 plus m2 into g. Let coefficient of friction is mu, then force of friction F between mass m1 and the surface is given by, this is force of friction at capital F between the mass m1 and level surface, and is given by F is equal to mu into capital R. Putting the value of capital R, F become equal to mu into m1 plus m2 into g. Let it be equation number 2. As the masses are moving with constant velocity, therefore according to Newton's second law of motion, capital T minus F is equal to 0. That is, net force acting on the system will be equal to 0. So T minus F is equal to 0, or T is equal to F. T is equal to mu into m1 plus m2 into g, that is putting the value F. Let it be equation number 3. From equation 1 and equation 3, capital T tension is same, therefore mu into m1 plus m2 into g is equal to m3g, or mu is equal to m3g upon m1 plus m2 into g. Now g and g cancel with each other, therefore mu is equal to m3 upon m1 plus m2. Putting the values of m1, m2 and m3, mu is equal to 2 upon 8 plus 2, or mu is equal to 2 upon 10 is equal to 0.2. Let it be equation number 4. Now when 2 kg block is removed from the 8 kg block and attached to the hanging block, see in the diagram, m2 is removed and placed over mass of block m3. Let tension in the string is now T1. See in the diagram, the tension changes, and let it be T1. Free body diagram of mass m2 and m3 is, this is m3 block and this is block of mass m2. Now force acting on it is T1 tension in the upward direction, and total weight acting in the downward direction m2 plus m3 into g. Let acceleration is A in the downward direction, that is downward direction force is greater. So let acceleration in the downward direction is A. Then according to Newton's second law of motion, m2 plus m3 into g minus t1, net force is equal to m2 plus m3 into A, acceleration. Let it be equation number 5. Free body diagram of mass m1 is, now this is mass m1. The various forces acting on the mass m1 are the tension capital T acting in the horizontal direction. This is tension capital T acting in the horizontal direction along the chord. The weight of the mass m1 acting in the downward direction, that is m1g. The normal direction r1 acting in the upward direction, this is normal direction capital R1 in the upward direction. As there is no motion in the vertical direction, therefore R1 is equal to m1g. Let it be equation number 6. Therefore The force of friction F1 now between mass m1 and the surface is given by, this is force of friction F1 between the block m1 and friction between the block of mass m1 and level surface given by F1 is equal to mu r1. Putting the value of r1, F1 is equal to mu m1g. Let it be equation number 7. From equation 6, put the value of r1 is equal to m1g. F1 become equal to mu m1g. As the acceleration of masses m2 and m3 is a in the downward direction, therefore acceleration of m1 is a in the horizontal direction. See in the diagram, the acceleration a is along the string in the horizontal direction. Therefore, according to Newton's second law of motion, T1 minus F1 is equal to M1A. Mean net force T1 minus F1 is equal to M1A. Putting the value of F1, we get T1 minus mu M1G is equal to M1A. Let it be equation number 8. Now solving equation 5 and equation 8. This is equation number 5. M2 plus M3 into G minus T1 is equal to M2 plus M3 into A. This is equation number 8. T1 minus mu M1G is equal to M1A. Now add them. T1 minus and T1 plus cancel each other. So what we get? M2 plus M3 into G minus mu M1G is equal to M2 plus M3 into A plus M1A. Now solving above equation. So we get M2 plus M3 plus M1 into A, take A common, is equal to M2 plus M3 minus mu M1 into G, or putting the value of M1, M2 and M3, 2 plus 2 plus 8 into A is equal to 2 plus 2 minus 0.2 into 8 into G. So 12A is equal to 4 minus 1.6 into G. 4 minus 1.6, 4 minus 1.6 is 2.4. So we get A is equal to 2.4 upon 12, or into G value is 10. So we get A is equal to 24 upon 12, or is equal to 2 meter per second square. So this is the value of acceleration of the system. Now from equation number 8, T1 minus mu M1G is equal to M1A. Putting the values, so we get T1 is equal to M1A plus mu M1A. Now put the values of M1, A and mu in G. So T1 is equal to M1 into A plus mu G is equal to 8 into 2 plus 0.2 into 10. 0.2 into 10 is, it becomes 2. So T1 is equal to 8 into 2 plus 2, or is equal to 8 into 4. 8 into 4 is 32 Newton. So T1 tension is equal to 32 Newton. So this is our answer. The acceleration is 2 meter per second square, and tension in the string or tension in the cord is 32 Newton. So thank you very much.